All right, so we're doing section 3.5 part B. That's the back of the homework that I gave you, numbers 9 through 14. We'll do 2 of them, okay, together. And then after that, I'll let you guys work on 4 of them. Maybe we'll do 3. We'll see how long it takes. But every single one of the problems, you're going to use something called Descartes' rule of signs. Now, Rene Descartes is the guy who actually created the grid. So you can see right here, right? The X, Y axis, all that. He created that. So it's his fault. But he also created other theorems, other rules for us to figure stuff out. One of those rules was the rule of signs. The rule of signs is used to figure out uh, how many real solutions we have, how many positives, how many negatives, and then from there we can figure out how many complex. Now, for him, he wrote a way to do it. There's like a general way to write it out, but I'm going to kind of give you a more condensed form. Okay. So here's the more condensed form. So the rule of signs, because it is pretty wordy. Maybe after I write this out, I'll read the actual one to you so you can see what I'm talking about. Okay. But the rule of signs basically says this. So first, count the number of sign changes of f of x. Okay. Count the number of sign changes of f of x. So your real function, you're going to look to see how many times it changes signs within the problem. And then that number represents the total positive zeros of the problem. So the positive zeros. So if I look at f of x and I count how many times it changes signs, let's say it's 3, then it represents the number of positive zeros, 3 positive zeros, okay, of that problem. And then in parentheses, I'm going to put or less than that by an even number. And this part kind of doesn't make a lot of sense, so I'll make sure I explain that to you guys when we do this. We're going to be using charts. Okay, it's the easiest way to do this. So there's 2 things you're going to have to do. First, you're going to count the number of sign changes of f of x. However many that is. If there was 3, great, there's 3. That number is going to represent the total positive zeros. So if, like I said, if it was 3, then there's 3 positive zeros. And then the thing in green says, or less than that by an even number. Well, what's the smallest even number that we know? What's the smallest even number? Not 0. It's 2, right? So if you have 3 answers, if they say, well, less than that by an even number, so subtract 2 from it. That means, or if there can only be 1, maybe. So 3 or maybe 1, because you're subtracting by an even number. If I found 5 answers that are positive, less than that by an even number means take out 2. So 3 maybe, or maybe just 1. Okay, so you're always reducing by 2. Always reducing by 2. Again, we're going to make a chart so it makes more sense. Okay, so that's one step. The second step is basically doing the same thing, but for f of negative x. So count the number of sign changes of f of negative x. Not f of x, f of negative x. So you're going to have to kind of alter your original function a little bit. That number represents the total negative zeros. The total negative zeros of the problem. So, or less than that by an even number again. So let me write that down. Or less than that by an even number. So f of x gives you the positive reals. F of negative x gives you the negative reals. Okay, so negative zeros. And then whatever's left over, we count them as complex solutions. Okay, so I'm going to put right here complex solutions come in pairs. Okay, so we're going to have to fill those in at the end. So complex solutions come in pairs. I know this does not sound in any way, shape, or form simple, but it's not that difficult once we start to see how it's used. Okay, but right now when you read this, you're like, what the heck, you told me this was going to be the easy way of stating it. It is. There's a more complicated way. I was going to write the actual definition. I'll read the actual definition to you guys really quick. It says, let f of x be a sub n x to the n plus dot 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 plus a sub 1x plus a sub 0 be a polynomial function with real coefficients and a sub 0 not equal to 0. Then the number of positive real zeros of f of x is the same as the number of changes in sign of the coefficients of the terms, or less than that by an even number. And the number of negative real zeros of f of x is the same as the number of changes in sign of the coefficient of the terms of f of negative x, or less than that by an even number. That's the actual definition. This is me just kind of rewriting it in sections. Okay? Don't get scared of it. All right, don't get scared. But let me show you. We're going to do some homework problems here. Let's start off with number 9. Okay, so we'll check out number 9. Oh, so you're 2-1, the 4. Oh, nice, nice. I was watching the tennis girls playing, and they were struggling, but I guess they pulled it off, so that's good. So number 9. Okay, we're going to state the possible number. This is the instruction for all 9 through 14, okay? State the possible number of positive, negative, and imaginary or complex, and imaginary zeros. Again, this is the directions to numbers 9 through 14. And we'll start with number 9. If you want, I'll do 3 of them just to kind of get some more out of the way, but yeah, go ahead. Do me a favor, make a pass. So number 9 looks like this. They put g of x, not f of x, but it doesn't matter. 3x cubed minus 4x squared minus 17x plus 6. So we're going to do step 1. Okay, step 1 says, let me kind of go back up really quick and then I'll come down. But look what step 1 says. Just count the number of sign changes in the original function. So in g of x, just count the number of sign changes. So here we go. G of x is given to me. Let's see how many times it changes signs. We're starting at 3. That's a positive 3, correct? And then it goes to a negative 4. Did it change a sign? From positive 3 to a negative 4? Yes, it did. That's one sign change, okay? That's one sign change. Now, from negative 4, it went to negative 17. Did that change a sign? No, they're both negative. From negative 17, it goes to a positive 6. Did that change signs? Yes, it did. So that's the second time. So how many positive real zeros can I have? 2. Or subtract by 2, what happens? 0. Positive real zeros. There's my answer for how many positive real solutions can you have. I can have 2 because that's how many times it changed signs. And then that part in green that I wrote, or less than that by an even number. So 2 minus 2 is 0. So maybe I'll have 2 positive answers or no positive answers. Now don't keep subtracting because you can't have like -2 positive answers. Like the number of solutions has to be either 0 or bigger. Okay, so I'm either going to have 2 positive real zeros or none because I'm subtracting by 2. Just so we can remember, how many solutions am I supposed to have for something like this? Anybody remember this from yesterday? How many? 3. Yeah, I'm supposed to have 3 of them, right? Because the power, the degree is 3. So I'm supposed to have 3. Okay? If I have 2 positive answers, then there's only room for 1 negative one. Okay? So we're going to find out the negatives right now. Let's find g of negative x. So g of negative x. That means I'm going to plug in negative x into this function right here. Instead of x and x here, I'm going to plug in negative x. So here you go. This is what it looks like. 3 times negative x cubed minus 4 times negative x squared minus 17 times negative x plus 6. So I just plugged in a negative x into my original problem. Okay? Oh, which, by the way, let me put a box around this because that's going to be my answers for the positive reals. Okay? But now I got to do the other part, the negative reals. So let me simplify that. So g of negative x is, well, negative x to the third is negative x cubed. So this will be negative 3x cubed. Negative x squared is just x squared. So that's going to be minus 4x squared. Negative 17 times negative x, bless you, that's positive 17x. And then a positive 6. So all I did was I plugged in a negative x and I simplified it, okay? I just simplified it. That's it. I didn't do anything crazy, just simplified it. Now, let's check sign changes. Negative 3 goes to negative 4. Is that a sign change? For that one? No. Negative 4 goes to positive 17. Is that a sign change? Oh, thank you. So, sorry, from negative 4 to 17, that is a sign change, right? That's 1. From positive 17 to positive 6, is that a sign change? No. From positive to positive, no sign change. So, how many negative real zeros can I have? 1. So I'm going to put step 2. I can have 1 negative real 0. Okay? So 1 negative real 0. All right. Now I got to put it all together. Now, if you're wondering, why didn't I subtract 2 from this one? Because I don't want negative numbers. 1 minus 2 is negative 1. I don't want to use that. Either it stops at 0 or it has to be positive. Okay? So a 2 or a 0, that's great. A 1 is fine. But if I subtract 2 from here, I end up with negative 1. I don't want to do that. Positive. So it has to be 0 or higher. Okay? So remember how I told you we're going to use a chart because we got to list everything? So here we go. So this is the way I used to make my chart. Positives, negatives, imaginaries, okay? And I'm going to kind of go down this way. I'm not sure how long I got to make this, so I'm just going to kind of do it like that. Okay. Now, Actually, let me put total right here so we can have a total amount. Now, how many answers was I supposed to have? We said 3 total, right? When he comes back. So we're supposed to have 3 total, right? So we're supposed to have 3 total. If I have 2 positive ones and 1 negative one, how many imaginaries can I have? If I have 2 positive and 1 negative, well, that's 3 already. So I can't have any imaginaries. So 2 plus 1 plus 0 is 3, okay? You can just put like an equal sign if you want, so it can help you out there, okay? Now, what if I had 0 positive ones? Okay? Because remember, my options were 2 or 0 right here. 2 or 0. And my negatives are 1. So what if I have 0 positive answers, but 1 negative one? How many imaginaries can I have then? 2. And remember, they always have to come in pairs. So you can't just say 1. They have to come in pairs. So 2. And that equals to 3. This is your solution to the whole problem. Okay? This is the solution to the whole problem. You have to figure out how many positive options you have, how many negative options you have. Okay? Notice for the negative options, I don't have anything other than 1. I didn't have like 1 or 3 or 5. I only had the 1. But for the positive ones, I could have had 2 answers or no answers, right? So once I choose my options, then I have to figure out my imaginaries. Whatever happens, when I add them to the side, they better equal to the total degree, which is 3. Okay? So 2 positive, 1 negative, and no imaginaries, that's 3. No positives, 1 negative, 2 imaginaries, that's 3. They have to add up sideways. Okay? So all we're doing is sign changes for f of x, sign changes for f of negative x, and then once we know our options, we build this chart and we try to make it fit the total number of answers. So for us, it was 3. So let me do another one. Then maybe we'll do a third one just in case, just to kind of give you enough of an idea of what's happening. So let me see. Let's look at number 14. I'm going to jump to 14 because that one looks like it might be the hardest of all of them. And it looks like this. F of x equals to x to the 4th minus x cubed minus 5x squared plus 6x plus 1. Remember, we're trying to figure out how many positive solutions it has, how many negative solutions, how many imaginary solutions. How many solutions does this one have total? Well, what's the biggest number? 4, right? 4, because that's the degree, right? The degree is 4, so that means I'm looking for 4 total answers. Okay? So the first part that we're going to do is we're checking for the sign changes of f of x. So let's see. Positive 1 to a negative 1. That's one sign change. Negative 1 to a negative 5. No sign change. Negative 5 to a positive 6. That's another sign change. So that's 2 so far. Positive 6 to a positive 1. That's no sign change. So 2 total sign changes. Thank you. 2 total sign changes. So either 2 or 0, positive, real zeros. Again, why 0? Because you're supposed to subtract whatever number you found by 2. Keep subtracting until you either get to 0 or once it becomes negative, you stop. Okay? So 2 or 0. Now let's find our negative ones. So f of negative x. So I'm going to plug in a negative x into my equation. Negative x to the fourth minus negative x to the third minus 5 times negative x squared plus 6 times negative x plus 1. So again, I'm just plugging it in. I don't have to like multiply stuff out or anything. I'm just plugging it in, and I'm going to simplify it right now. So negative x to the fourth. Well, that's x to the fourth. If you have, okay, go. So this is going to be x to the fourth. Now, minus negative x cubed is negative x cubed. So it's going to make this a plus x cubed. Minus, well, negative x squared is just x squared times 5 is 5x squared. So I'm going to put 5x squared right here. 6 times negative x is negative 6x. So minus 6x. And then plus 1. So that's my new function, and I'm going to figure out how many sign changes occur. So I'll give you guys a little bit of time to write that down, and then right now we'll do the sign changes. So a 1 to a positive 1, not a sign change. Positive 1 to a negative 5, that's one sign change. Negative 5 to negative 6, not a sign change. Negative 6 to a positive 1, that's a sign change. So how many sign changes do I have for negatives? Well, 2 or less than that by an even, so or 0. Okay, these are negative real zeros. So I can either have 2 positive or no positive. I can have 2 negatives or no negatives. So let's make a chart with this. So here we go. Positives, negatives, imaginary, and total. I don't know how long this chart's going to be, so I'm just going to make it a decent size. Let's start with the 2 positive. Okay. My total we said was supposed to be 4, right? So total is 4. What were my options for the negatives? It was 2 or 0, right? So if I have 2 positive and 2 negatives, how many imaginaries can I do? 0. Thank you. What if I had 2 positives but no negatives? Because that's also an option for my negatives. None. How many imaginaries can I have then? 2. Because that still equals 4. Okay? Oh, thank you. Now, so I've exhausted my positive options. 2, okay, I used it twice because I did 2 positives with either 2 negatives or no negatives. Okay, now let me do no positives. If none of them are positive, remember negatives could either be 2 or 0. So either 2, that means I can have 2 imaginary, that equals to 4. Or no positives, no negatives. How many imaginary in this case? I get 4. That's equal to 4. This right here is your answer. Right now I'm going to go ahead and explain it, how to do this. But this is from Mario. So I know this isn't like super simple. We're not doing multiplication and plugging in numbers and doing all this extra stuff. I know that, but it doesn't make this simple. Okay, so let me just kind of explain it again, just to kind of hopefully get it to make sense to you. So positive solutions, we had 2 options. It was either 2 or none. Okay, 2 or none. So I started off with, what if we had two positives? Then I said, what are my options for the negatives? Well, the negatives, I could either have two or none. So if I was going to use two positives, then I could either have two negatives or no negatives. So two positives, I was going to stick with the two positives, but either two negatives or no negatives. If I did two negatives with two positives, that equals 4 already. So I can't have any imaginary, okay? Because it's supposed to all equal to 4. If I did two positives with no negatives, well, I'm at 2 so far. That means I need 2 more. So that gives me 4. Okay, now that I've done the positives at 2, let's do positives at 0. So in other words, there are no positive answers. If there's no positive answers, I still have the option of 2 negatives or no negatives. So no positive answers with 2 negative answers, I need 2 more to equal 4. Okay, this is the key, the total, because you got to make sure it totals up sideways. If I have no negatives with, no positives with no negatives, I need to have 4 imaginary. Remember, imaginaries always come in pairs, so they either come in 2, 4, 6s, 8s, okay? They don't come in 5s or 3s or 1s. So this is the chart that tells me how many positive and negative answers you can have. Okay, do you want me to do one more for you guys so you only have 3 to do for homework? And anybody want me to do a third? Okay, so we'll do a third. Do you want it to be harder or easier? This is the hardest one, by the way. So, I'm gonna pick one. Let's see. All right. Well, it's closer to 11, so we're gonna do 11. I'll try to do this one a little bit faster. I know you're kind of like, oh my gosh, this is taking forever, but I think the more of these you see, the more it might make sense, hopefully. So here's f of x. X cubed minus 8x squared plus 2x minus 4. So today you only have 3 problems for homework, not 4. So the easy one is the positive answers, right? Because you don't have to do anything, just count the sign changes. So here we go. Positive 1 to negative 8, that's 1. Negative 8 to a positive 2, that's 2. Positive 2 to a negative 4, 3. So there's a total of 3 changes in signs. That means that I have 3 or what? 1, right? 3 or 1. Because you got to subtract by 2. Now, if you're thinking, well, why didn't you keep subtracting? Because 1 minus 2 is negative 1. Remember, no negatives. We don't want negatives to be like the number of solutions we have. So 3 or 1, positive, real, zeros. Now, the next part is the tough part, the one I always used to struggle with when I was doing this in high school. Plugging in a negative x. So here we go. Negative x cubed minus 8 times negative x squared plus 2 times negative x minus 4. And now I got to simplify it. Okay? I got to simplify it. So negative x cubed is still negative x cubed. Minus 8 times negative x squared is just x squared. So that's going to be minus 8x squared. 2 times negative x is negative 2x minus 4. Okay? So let's figure out the sign changes for this one. So from negative 1 to negative 8, it does not change signs. From negative 8 to negative 2, does not change signs. From negative 2 to negative 4, does not change signs. So how many negative solutions can I have if it never changed signs? 0. 0, negative, real, zeros. In other words, none of the answers to this problem are negatives. They're either positives or they're probably going to be imaginaries. We'll see. Okay. All right. Now we make our chart. Positives, negatives, imaginaries, and the total. All right. Positive real numbers. I either can have 3 or 1. Okay, so let's start with 3. Okay, and the total is how many is this supposed to be total number of answers for this one? 3, right? X cubed to start. So it's supposed to add up to 3. So if I have 3 positive, how many negative and imaginary can I have? 0, right? Because 3 plus 0 plus 0 is 3. Okay, great. So if I have 3 positive, then I can have no negatives, no imaginaries. Well, what if I have 1 positive? How many negatives can I have? Kind of like a trick question. How many negatives can I have? 0. I can't have like 2 because they're not letting me have anything other than 0. So 0 negatives, which means how many imaginary can I have? 2. And that's 3. And this problem is done. If you're wondering, well, how do you know it's done? Well, because I've exhausted my options for positive real solutions. I can either have 3 or I can have 1. I can't have 0. I can't have 2. Either 3 or 1. So that would be my answer to this one. So if you have 3 positives, that's all you're going to get. If you have 1 positive, you'll get 2 imaginaries. So if you guys go home today and you're trying to do this and you're like, I don't get it, okay? When you guys come back on Monday, tell me, and bless you, and we'll do them so that you can see them, okay? But we'll do them together.